Just before 7:15 a.m. on May 26, 2026, a 900,000-gallon chemical storage tank at the Nippon Dynawave Packaging facility in Longview, Washington, collapsed inward. First reports called it an explosion. Emergency responders quickly corrected the official record. It was a vacuum implosion. 11 workers lost their lives in Washington state's deadliest industrial accident in nearly a century. This account is built directly from the U.S. Chemical Safety Board incident docket for the Nippon Dynawave fatal tank collapse and the published inspection filings of the Washington Department of Labor and Industries. It examines the precise structural mechanics and statutory process safety exemptions that left a massive chemical vessel vulnerable to immediate collapse. The Nippon Dynawave Packaging mill sits along the Columbia River in Cowlitz County, operating deep inside the heavy industrial manufacturing corridor of the Pacific Northwest. The facility produces liquid packaging board, the heavy food-grade paperboard used globally for juice cartons and liquid containers. At the core of paperboard manufacturing is the kraft pulping process. Wood chips are cooked under pressure in chemical digesters to separate cellulose fibers from natural wood lignin. The primary chemical engine driving this separation is white liquor. White liquor is a dense, highly alkaline solution made primarily of sodium hydroxide and sodium sulfide. To maintain continuous round-the-clock mill operations, facilities hold hundreds of thousands of gallons of white liquor in massive industrial storage vessels. These tanks are constructed from heavy structural steel. They are engineered to sustain immense fluid weight, pushing outward against the lower ring walls. Because white liquor is continuously pumped into production lines and replaced from chemical recovery boilers, fluid levels inside these tanks shift constantly. As fluid level drops, the empty volume inside the vessel must instantly fill with air to equalize internal pressure with the surrounding atmosphere. Equalization relies on dedicated roof venting systems. If an atmospheric storage tank cannot breathe while fluid moves, atmospheric pressure outside the vessel becomes a crushing force. On the morning of May 26, 2026, the 7 a.m. shift change was underway across the Longview mill grounds. Workers were transferring duties, conducting crew briefings, and walking between active production bays and adjacent administrative spaces. At 7:15 a.m., operational adjustments were executed on the main liquid transfer lines connected to Tank G. Tank G was a 900,000-gallon atmospheric storage vessel containing heated white liquor. As pumps drew thousands of gallons of heavy fluid out of the vessel, liquid dropped rapidly. The tank's atmospheric air intake system failed to equalize the internal volume. Within seconds, liquid displacement created a vacuum pocket inside the sealed upper section of the tank. The external atmosphere exerted a uniform crushing pressure of 14.7 pounds per square inch against the thin outer steel shell. Thin-walled steel vessels can resist hundreds of pounds of outward fluid force, but they are exceptionally weak against inward pressure differentials. A negative pressure differential of just 1.5 pounds per square inch was enough to exceed the structural buckling limit of the vessel walls. Tank G did not rupture outward. The top roof structure collapsed inward, and the upper shell walls folded like paper. The sudden structural collapse displaced nearly 1 million gallons of boiling caustic liquor. The fluid breached the surrounding earthen containment dikes, inundating nearby walkways, utility trenches, and lower-level break spaces. 11 employees were caught in the immediate inundation path, while 8 others sustained severe chemical burns and blunt impact injuries. The reason an industrial vessel of this size could collapse under simple atmospheric pressure is not a mystery. It is documented in the statutory text of federal process safety regulations. I will show you the exact exemption in the code that allowed this hazard to sit uninspected. Local emergency services and hazmat teams arrived at the facility within minutes of the initial 911 dispatch. Rescue operations were immediately hindered by standing pools of high pH caustic chemical solution, toxic hydrogen sulfide vapors, and unstable steel debris from adjacent pipe racks. State and federal regulatory authorities initiated immediate investigative steps. The U.S. Chemical Safety Board dispatched a specialized field team to secure site telematics, pump telemetry, and physical valve components. Concurrently, the Washington Department of Labor and Industries opened an administrative enforcement investigation under state occupational safety statutes. Investigators systematically reconstructed the operational history of Tank G. They audited control room SCADA logs, maintenance work orders, and physical relief valve assemblies. Physical evidence showed that the tank's vacuum relief mechanisms had suffered long-term internal corrosion and salt crystallization, jamming the internal seats closed. When high-capacity pumps were engaged during the morning shift, the jammed relief valves prevented external air from entering the vessel shell, pulling the tank into a lethal negative pressure state. The Longview mill facility operated under a complex corporate structure. Nippon Dynawave Packaging was formed as a joint venture, acquiring the liquid packaging board operations from Weyerhaeuser in 2016. The physical infrastructure of the mill included assets built across several different regulatory eras. Tank G was constructed during a facility expansion decades prior, designed under standard industrial codes for atmospheric liquid storage. Over decades of continuous operation, responsibility for routine mechanical integrity checks passed through multiple operational teams and evolving corporate safety management systems. The immediate operational impact was severe. The Washington Department of Labor and Industries issued emergency stop work orders across the entire pulp recovery circuit of the Longview mill. The Chemical Safety Board designated the site an active formal investigation zone, halting chemical processing across adjacent lines. Civil filings were initiated by surviving workers and families of the deceased, alleging gross negligence in facility maintenance and systemic failure of site mechanical integrity programs. State environmental regulators established continuous monitoring downriver along the Columbia River to evaluate neutralized chemical runoff from emergency containment basins. Most news reporting and public commentary framed the Longview catastrophe as a mysterious industrial explosion or an unpredictable equipment failure. Media coverage focused heavily on the visual aftermath and initial confusion surrounding the shift change casualties. However, a systematic examination of the primary regulatory record reveals a fundamental statutory gap. Under federal OSHA process safety management standards, codified in 29 CFR 1910.119, chemical facilities operating complex manufacturing processes are required to establish comprehensive process safety management programs. These rules mandate formal mechanical integrity testing, written operating procedures, and strict inspection cycles for critical process equipment. The enforcement mandate of 29 CFR 1910.119, Appendix A, relies on a specific list of highly hazardous chemicals. If a vessel contains a chemical listed in Appendix A above specified threshold quantities, it is subject to mandatory federal process safety audits, mandatory relief valve testing, and formal management of change procedures. White liquor is an aqueous solution of sodium hydroxide and sodium sulfide. Sodium hydroxide is intensely caustic. It inflicts severe chemical burns on contact and rapidly destroys organic tissue. Yet, in the statutory framework of federal process safety management rules, sodium hydroxide is classified strictly as a corrosive skin hazard, not a volatile or explosive compound. As a result, sodium hydroxide and sodium sulfide solutions do not appear on the regulatory list in OSHA 29 CFR 1910.119 Appendix A. Because Tank G held white liquor rather than a volatile hydrocarbon or flammable solvent, the vessel fell into a clear regulatory exemption. Federal process safety rules did not mandate formal, documented vacuum relief testing cycles for atmospheric white liquor tanks. The vessel was managed under general occupational safety standards, which rely on self-monitored visual inspections rather than rigorous mandatory engineering audits. Technical guidance for atmospheric storage tanks is governed by American Petroleum Institute Standard 2000. API 2000 establishes exact engineering standards for venting atmospheric and low-pressure storage tanks. It explicitly warns that atmospheric tanks possess minimal resistance to internal vacuum pressure. The standard outlines specific calculations to ensure vent capacity matches maximum liquid withdrawal rates. Despite the published guidance of API Standard 2000, industrial operators were not legally bound by federal process safety law to conduct mandatory non-destructive testing on Tank G's vacuum relief systems. The regulatory framework focused heavily on preventing overpressure, fire, and chemical explosions. It left thin-walled atmospheric storage vessels holding highly corrosive non-flammable liquids, entirely unmonitored for atmospheric vacuum hazards. Under federal law in May 2026, a vessel holding 10,000 pounds of flammable propane was subject to strict, mandatory, federally audited mechanical integrity checks. A vessel holding 900,000 gallons of toxic, highly caustic white liquor was exempt from those same statutory process safety requirements. The omission sat in the text of Appendix A for decades, invisible to the public until a jammed vent valve pulled an atmospheric steel tank past its breaking point. Following the release of preliminary findings by the Chemical Safety Board, industrial safety advocates and labor unions called for immediate administrative updates to federal process safety definitions. The Washington Department of Labor and Industries launched a comprehensive compliance audit of all pulp and paper manufacturing facilities operating within state jurisdiction. Industrial operators across the Pacific Northwest initiated emergency engineering reviews of atmospheric chemical storage vessels, focusing specifically on vacuum relief valve integrity and vent capacity calculations. Representatives from the Chemical Safety Board emphasized in public statements that vacuum collapse is one of the most predictable and preventable hazards in industrial chemical engineering. The agency reiterated that mechanical integrity programs must cover all hazardous fluid storage, regardless of whether a substance meets the narrow statutory criteria for fire or explosive toxicity under old federal standards. Safety regulations do not fail because engineers misunderstand the laws of physics. They fail when legal definitions classify a hazard by what burns, rather than what can crush a steel structure under the weight of the surrounding air. The primary investigation docket remains open under U.S. Chemical Safety Board Incident Number 2026-04 XI-WA. Full citations, regulatory text excerpts, and court filings are linked in the description below. If you want more videos that trace major industrial disasters back to the official documents that explain them, subscribe to the channel.